Topic 4, Objective 2. Use long division to prove the remainder theorem and factor theorem. So now this is where we're going to start dividing factors from polynomials, all right? Long division is a tedious process. There's two types of division, long division and synthetic division. Long division is the harder one. I have to show you both because depending on the factor in question, you have to use one or the other. And so with this, please just, as much as you can, follow it step by step and being very careful where you put your answers, and you have to line up like terms, and there will be places where some steps cause more of an error or are more prone to errors than others. So I'll try to make note of that as I'm doing this. But just please keep in mind that it's a very step-by-step process, and you have to work very neatly as you're doing this, showing all of your work, okay? Please don't take any shortcuts while you're doing this. I'm going to do 3 different things for each problem. I'm only going to do one example, and then I'm going to have you pause the video and try an example on your own. But for all of these problems, please, first thing, state the number of roots that exist, the fundamental theorem of algebra, and then divide using long division. And then once you're done, based on if it has a remainder or not, state if the divisor is a factor of the given polynomial. So I've listed out the steps I'm going to take to do this process. The polynomial in question is the bigger one, 7n to the 4th plus 11n cubed minus 30n squared minus 2. And it's asking to divide 7n minus 10 from it. All right. So the first thing that clues me that I have to use long division if I'm working on a test or anything else is that the factor in question right here, the 7 before that n would make the solution not a very pretty one. It would be a factor, because if I were to set that equal to 0, 7n minus 10 equal to 0 and solve, plus 10, 7n equals 10 divided by 7, n would equal 10 sevenths. Because the root is a fraction, I would want to use long division. So the 7 before that n tells me that I should use long division. Or if there's a power with the factor, so if it was n squared, I would also have to use long division. All right, synthetic division can be used, and it's easier, and I'll tell you when you can use synthetic division. But if there's ever a number before the n of the factor, you have to use long division. All right. Now, the first step, if I'm going to do this, is I'm going to write in long division format, and that's a skill probably from elementary school. The first step here, I'm going to use the division box. If hopefully that looks familiar to you. Inside the division box goes the dividend. Please label this dividend. So 7n to the 4th plus 11n cubed minus 30n squared. If you notice, there's a pattern that's happening. It went from 4 to 3 powers. The power of 4 to the power of 3, the power of 3 to the power of 2, but it skipped one. It jumped over the linear power, or the power of 1. Whenever it skips a power in the polynomial that you're trying to divide something from, you have to use what's called a space holder. The space holder is 0 with the variable in the power of whatever is missing. So in this case, I'm going to use plus, I'll write it in red, plus 0n. Because I need the power of 1, because I need to have these line up perfectly. Otherwise, my spacing might be thrown off in this process. Sometimes it won't, but sometimes it will, and so we need it to help us with it. And then finally, I'm going to add the minus 2 to complete my polynomial. All of this exists underneath the division box. Outside the division box goes the divisor. All right, the divisor in this case, the factor in question is 7n minus 10. So if I divide this out, and at the end, if there is no remainder, then 7n minus 10 is indeed a factor, and the solution of that factor, 10 over 7, is indeed a solution of the polynomial as well. That's what the factor and remainder theorems state. Now, I just did step 1. I wrote it in long division format. Step 2 says you take the first term of the polynomial and divide it by the first term of the factor. All right? And then write the answer above the like term, goes on top of the division box, above the like term of the polynomial. I will do this in green. The first term of the polynomial is 7n to the fourth. All right, and I'm going to divide the first term of the factor by it, which in this case is 7n. If you can do this in your head, fair enough. If you can't, please, you have to use side math before you ask me a question so I can see your thought process with this. I'm going to make a little 1 here, and I'm going to signify I'm doing round 1 with this math. So the first term is 7n so this is the side math I would need to see. 7n to the fourth divided by the first term of the factor, 7n. 7 divided by 7 is 1. N to the fourth divided by n is n cubed. So my answer in step 2, or the first division that we're doing, is n cubed. If you notice, there's an n cubed right here. I have to line it up identically with that. The n cubed has to go above the cubes within the division box. That's why I needed my space holder, because if I ever have a linear answer or a power of 1, I need to line it up correctly. Okay? So in this case, n cubed. I'm done with step 1. Or step 2, sorry. Step 2 is pretty straightforward. I divided it out first term by first term, wrote the answer above the like term. Now, step 3 says to multiply the answer that we just got, which is n cubed, with the entire factor of 7n minus 10, and write the answer below the like terms of the polynomial. So, I'm going to show you this thought process. Step 3 down here. Actually, I'm going to change it to a different color. This is step 3, okay? Step 3, I'm going to distribute the n cubed back into the factor that we're using for division. So what that looks like, it becomes n cubed times 7n minus 10, just to help you visualize a little bit. So I'm going to distribute it back in there. And then once you multiply each term by it, you write the answer of each multiplication underneath the like term within the polynomial. So this time we're going below, okay? N cubed times 7n is 7n to the fourth. The fact that it's the same as the one above it should jump out at you, because one of the terms should cancel out eventually throughout this whole process. Now, n cubed times negative 10 becomes negative 10n cubed. And I line it up with the 11n cubed below it, all right? So I am done with step 3. I've multiplied the answer of division back into the factor to get a new polynomial, or the start of a new polynomial, okay? Done. Step 4 will give us a new polynomial to work with. Step 4 says to subtract the answer that I just got from the like terms of the original polynomial. Hint, when you do this correctly, one of the terms should cancel out. The term with the highest power, in fact. So step 4 I'll do in a different color. How about it? Step 4 is right here. I'm going to subtract. Whatever I'm subtracting, I need to put in parentheses, because that subtraction is going to act on each one of those terms, the 7n to the fourth and the negative 10n cubed. So first thing first, 7n to the fourth minus 7n to the fourth. That cancels out or becomes 0. So I found my hint, one of them canceled out, the highest power did. Now, 11n cubed minus a negative 10n cubed. If you notice, minus a negative, if you have ever had that situation, it becomes plus. So it's 11n plus 10n cubed is 21n cubed. All right? I am done with step 4. Step 5, the final step of this process, is you bring down the next term of the polynomial and repeat this entire process, okay? So step 5, I will do, what color haven't I used yet? Red, I suppose. The next term in this polynomial, I've already worked with the 7, that's gone. This one I've already worked with it, combined with this one to make the n cubed. So the next one is the n squares. In this case, it's negative 30 n squared. That's step 5. Bring it down. Now I'm going to repeat the entire process, starting back at step 2. Step 1 is already done. I'll do it again. Step 2. So I'm going to use green again. Step 2 states, I'm sorry, not green, purple. Step 2 states the first term of our new polynomial, right here, divided by the first term of the factor. That's the math we're doing. And then I write the answer above the division box, above the like term that exists. So in this case, round 2, the first term is 21n cubed now. If you notice, it was n to the 4th, now it's n cubed. I'm doing something right. Divided by 7n equals. So 21 divided by 7 is 3. N squared divided by n is n cubed divided by n is n squared. So my answer is now 3n squared. I need to write that above the division box and line it up with like terms. And it's a positive 3, so I'm going to write plus 3n squared. Now my n squares are lined up. My n cubes were lined up. All right? Now, that is done with step 3. I'm sorry, step 2. Step 3, I'm going to multiply them back in. All right? Multiply now my new term of 3n squared with each term of the factor. So it's going to be, my new step 3 is 3n squared times 7n minus 10. I'm just showing some side math or my thought process. 3n squared times 7n is 21n cubed. Notice they're the same, so they're going to cancel out. And then 3n squared times a negative 10 is a negative 30n squared. After I did that math. Done with step 3. And I wrote it below and I lined them up identically like I should have. Alright? Now step 4 says to subtract. And remember, whatever I put in parentheses, whatever I subtract, I have to put in parentheses. So now 21n cubed minus 21n cubed, those cancel out. Negative 30 minus a negative 30, it turns into plus. Negative 30 plus 30, those cancel out as well. So technically this was 0, this is 0. Now step 5 says to bring the next term down and repeat the process. But if you notice, the next term is just another 0, and you can't divide anything by 0. And so then finally, I didn't have to do any of those steps because it is just 0. So finally, I would bring down the last term to see if I can divide it by 7n. The last term is negative 2. But negative 2 can't be divided by 7n. First term by first term doesn't work. So when you reach this point, you have reached the end of the division process, okay? Negative 2, since it was the last thing that remained and you can't divide anything more out of negative 2, becomes our remainder, all right? So I'm going to use r for remainder is negative 2. So if you ever have a remainder, the way you write your answer, it was n cubed plus 3n squared. Now it's going to be minus 2 over 7n minus 10, the original divisor. So my final answer, after I divide out the factor, 7n minus 10 is n cubed plus 3n squared minus 2 over 7n minus 10. Now, the third piece of this, state if it's a factor or not. 7n minus 10 is not a factor of the given polynomial. And I know that to be true because it has a remainder. Alright, so it's not a factor. If it's not a factor, the solution of that original factor of 10 over 7 is not a root or a 0 of the given polynomial either. Alright, so go ahead and pause the video and try number 2 on your own and check your work with mine. Your problem. I divided everything out and I showed my work. I did cross things out as I was working, and if you did it exactly like me, you should have gotten a 0 for a remainder. So your final answer should be p squared plus 10p. I showed my side math over here as well. If you got p squared plus 10p with a remainder of 0, you did this correct. Now, to bring this home then, because there's no remainder, the original factor is a factor of the polynomial, and the root of that factor, negative 8/9, is a